what is the y? Oh, well, identify the axis of symmetry. So x is equal to 1. Very good. It is symmetric on that x value. The parabola is symmetric along that x value. What is my vertex? Over 1. We know it's on the axis of symmetry. It's over 1 up 2. So you would have wrote it as 1, 2. How many got those two right? Sweet. And is it a maximum or minimum? So that vertex is a minimum. It's the lowest point on our graph. Any questions on that? Okay, most of you got it 100%? Okay, good. Okay, so remember, today we're doing 6-4. I really like this lesson, but it does need to go fast or we're not going to get through it. So first of all, recall what we've learned with quadratics so far. We've learned that the standard form of a quadratic, now it's quadratic because it's degree 2, standard form of a quadratic is ax squared plus bx plus c, right? Where are we good to go, people? Where a, b, and c are the coefficients in front of the variables. A is always in front of x squared, b is always in front of x, and c is our constant coefficient. Then recall, we've learned how to find the axis of symmetry when dealing with something in standard form. It's x is equal to the opposite of b all over 2a. And then once we know the axis of symmetry, we can find the vertex. So we know it's on the axis of symmetry, it's that x value. You'll take that x value, and you'll plug it into your function. That will give you the y value of your vertex. Is everybody good so far? Then, remember that we've been able to find the y-intercept, which means we're across the y-axis. It's always when x is equal to 0. So you can take 0, plug it into our function, right? So, these are the things we've learned so far. Y-intercept is we're across the y-axis. We've learned how to find the vertex and the axis of symmetry. Today what we're going to be finding is where it crosses the x-axis. So these two places. Now this is one of the most important things in a quadratic, because guess what we're doing when we find those x-intercepts? So those are x-intercepts. Aren't those where it crosses the x-axis? Yes or no? So this, like I said, it's the most important thing when dealing with the quadratic, because what we're doing when we are finding those x-intercepts is we're solving the quadratic equation. We're solving the quadratic equation. So if I say to you solve, you're actually finding where those two values where it crosses the x-axis. So a couple things to note. So once again, we're going to find where it crosses the x-axis. There's a couple different things that can be called. Those are x-intercepts. They can also be called zeros. These are the zeros of the quadratic. So if I say to you find the zeros, you're simply finding where it crosses the x-axis here. If I say to you find the x-intercepts, you're simply finding where it crosses the x-axis. Same thing. Now also, if I say solve the quadratic, you're solving it, but what you're doing is finding where it crosses the x-axis. You're finding the zeros. Yes?
Why is that called zero?
Because that's where y is equal to 0.
Okay.
Good question. So understand something. We know parabolas are smiley faces or frowny faces. So it's always going to come up and come back down. So it's always going to cross the x-axis twice. So things to note. There's always going to be two solutions, two x-intercepts. Is that true?
Yeah.
Yeah. Do you understand why?
Yeah.
A parabola is always going to come up and come back down, right? Or up and back down. So it's always going to cross the x-axis in two places. Now understand something. The fundamental theorem of algebra sounds super fancy, but it's not. It's exactly what I just said. So everybody look up here. Quadratics are degree 2, right? That's the highest degree of 2, right?
Right.
So it should have two solutions. That's what the fundamental theorem of algebra says. So because it's squared, the highest degree is 2, there will be two solutions. So what if it was x cubed? How many solutions would we have? 3. It would cross the x-axis 3 places. What if I have x to the 4th? How many solutions am I going to have? 4. So do you understand that? What about x to the 1st? How many solutions am I going to have? 1. So once again, does everybody understand? Because it's quadratic, there will be two solutions every time. Okay, awesome. Yes?
Okay, you're saying the two solutions are based off the x-intercepts. What if, say, that negative parabola's vertex was below the x-axis?
Great question. Great question, Gary. So we're getting there right here. So everybody look at this picture here. We see it crosses the x-axis in two places, right? So we have x is equal to -6 and x is equal to 3, right? So if we solve this, doesn't that where it crosses the x-axis?
Yes.
Okay, well, Gary makes a good point. What if it doesn't cross the x-axis? So this is a good point. So guys, if something like this happens, because we can take a parabola and shift it up, can't we?
Yeah.
Can we take a parabola and shift it down?
Yeah.
So notice it's never crossing the x-axis. Now understand something. These are real numbers, right? These are all real numbers, right?
Right.
So if it doesn't cross, you're right. It doesn't have a real solution. But it does still have two solutions. They're just called imaginary solutions. So this still has two solutions, but they're imaginary. So with this, you could say, okay, so this one has two real solutions. It's crossing the x-axis. If it does cross the x-axis, they're definitely real solutions, right? It hits the real number line. Up here, you're right. It never crosses the x-axis. So it still has two solutions, though. It's still degree 2, but they're imaginary. So you would say it has two imaginary solutions or no real solutions, because it never crosses the x-axis. Does everybody understand?
Yeah.
Okay, we're going to get more in depth. So first of all, the first thing we're going to learn is how to find these using our graphing calculator. So let's look at my first example. I say to you, find the x-intercepts of x squared minus 25. Or if I say find the solutions, it's the same thing. So we're going to go ahead and use our graphing calculator. Pull it up. Here we go. Follow me through this, people. So everybody, you need to follow me through this. So you go to y equals, and we're going to type it in. So you'll type in, I'm going to give everybody a second to get their calculator. You're going to y equals right up here. Then we're typing in x squared minus 25. We want to graph it. So x squared and then minus 25. You can't type in negative 25. That won't graph it correctly. It'll say error. So does everybody have this piece typed in? Hit graph. So now we're going to look and see where it crosses the x-axis, because those are going to be our solutions. So it's crossing at, well, negative 1, 2, 3, 4, 5, right? And it's also crossing at 1, 2, 3, 4, 5. But you know what? We need to make sure. So we need to actually use our calculator to make sure that it's crossing the x-axis at negative 5 and positive 5. So this is how you'll do it. Because what if it was a decimal? Could you guess where it is? Not really, not accurately. So this is how you'll do it with your calculator. So you'll follow me through this, because this is a little bit hard for students at first. So you have to hit second trace. We're finding the zeros. So go down to number 2. Now we have to focus on 1 0 at a time. So right now I'm going to choose to find this 0. So notice how it says left bound. That means I need you to pick a number left of that x-intercept. So left bound, we've got to scroll. Look at that little dot. We've got to scroll and be left of it. Left means smaller. So everybody, I'm focusing on this 0. Do you see how I'm left of it? Anywhere left will work, as long as you're left of the 0. Do you understand what I'm saying? This is left of this point, is it not? Look from left to right with your eyeballs like you're reading a book. Do you understand how that's left of it? So I hit enter. It says right bound. So that means I need you to be right of the 0. So I scroll right with my arrow key. It can be anywhere right. Am I right of it? Yes. So I hit enter again. Now it's saying, do you want me to guess? Our calculator is going to guess correctly, so you hit enter again. So it tells you it's crossing, the 0 is at negative 5. So x is equal to negative 5 is one of our solutions. So we'll write that down. Okay, so we get x is equal to negative 5. So we know it's crossing at negative 5. And then we'll do the same thing for the other 0 here. Yes, Brendan.
Can you do it by 5 by plugging 0 in for y? And then just kind of pulling everything out. It said middle sign change.
You didn't do your left bound or right bound right. You're solving for algebraically, which we're going to get to in a minute. So I want you to practice with your calculator first. So now let's do the other 0. Second trace. We're going to find the other 0. So I go down to 0. We want to be left of it. So I'm focusing on this 0 over here now, right here. So I'm going left of it. Anywhere left will work. So do you see how I'm left of it?
Yeah.
Everybody?
Yeah.
Enter. Now it says right bound. I've got to scroll and be right of it.
How come it makes you do that?
Because you're giving it, like you're saying what 0 you want it to focus on. So it takes a point, does it, and it does all the averaging for you. So it knows where to look between. Does that make sense? So it knows it's looking for where it's crossing between this and this. Does that make sense? So now we're right of it. I hit enter. It says, do you want me to guess? I hit enter again. And it says x is equal to 5. So I'd use my calculator to make sure. So I get x is equal to 5. So crosses at 5. So for right now, a rough sketch is okay. You're not even sketching. I'm just showing you. So you all understand how to find the zeros, right? But now, let's graph this one, x squared plus 25. Yes?
If you just go in the table and see where y equals 0.
Yes, absolutely. Go right ahead. That's totally fine as well. Okay, so everybody, let's graph this one, x squared plus 25. So, I'm typing that in. X squared plus 25. I hit graph. Now, everybody hit graph. How many of you, you can't see the parabola? Awesome. So that means your window's not good enough. You're not seeing high enough up. So don't we know that x squared plus 25 takes our parabola, it shifts it up 25 units?
Yeah.
We learned that on the day 1 of quadratics. So don't we need to at least see as high up as 25 on the y-axis? In fact, we want to see higher up. So you got to go to your window. So everybody go to window. In y max, that's how high up you're seeing. If it says 10, your window's only showing up to 10. Change it to something larger, like 50, because you need to at least see up to 25. Do you all understand what I'm saying?
Yeah.
So you change it to 50, hit graph again, and you will see your quadratic. Is it ever crossing the x-axis? No, so it has no real solutions, right?
Right.
No real solutions. Okay, so that would be our answer for this one. No real solutions. So it looks like something like this. No real solutions. Is everybody comfortable with doing it by yourself now?
Yep. See.
Okay, do 1 through 9 by graphing. Ready, set, go. And then we're going to learn how to do it algebraically, which is my ultimate fave. Ready, set, go.
Hey.
The harder you work, the less homework you have. First hour, didn't go home with any. You guys, everybody look at number 7. Now notice something. It says x squared minus 15 is equal to negative 15, right? So look at all the other problems. Weren't they already equal to 0? All the other problems were equal to 0. So to be able to solve a quadratic, we need to make sure it's equal to 0 first. So I forgot to say that. So the other ones we didn't have to do anything because they're already set equal to 0. But this one we need to get set equal to 0. So we need to bring this negative 15 over, right?
Yeah.
So that it's 0?
Yeah.
So I'm going to add 15 to both sides. Add 15. So we have x squared plus 0. Isn't that 0? Is equal to 0. Isn't that 0? So really we have x squared is equal to 0. So isn't that going to just look like this? Ding, ding. Yeah? Isn't it going to just look like that? Isn't that our basic, most parent function from quadratics? So where's it touching down? At what x value?
0.
0. So x is equal to 0. It's only touching down at one spot. X is equal to 0. Does that make sense, everybody? Okay. So keep working. So a couple of good things to note. Brendan brought up a good point. He said, well, we know if they have the form, a couple days ago we learned if they have the form ax squared plus c, that's taking the parabola and shifting it up or down, right? So if we had something that was positive here, such as x squared plus 64, aren't we taking our parabola and shifting it up 64 units? So is it going to cross the x-axis?
No.
No. So what if I had x squared plus 3? Is it going to have a real solution when we take our parabola and shift it up 3 units? So good point. I just wanted to bring that up. Brendan was able to think through that and say, okay, so if it's something like this, it's always going to be no, or even if it was like this, it would be no real solutions. Good point. And then he also said, okay, but that's thinking a little bit more in depth here. If it's negative 2x squared minus 3, the negative flips it upside down, right? And if it shifted down 3, then it would look like this. This would also have no real solutions. So good point. So one more thing I want you to know, thinking a little bit more advanced, and in secondary 3 you get this advanced, but I want you to think. So does it only touch our x-axis in one place with something like this? Yes. So this one would be x is equal to 0. But because, now this is more advanced than we really need to think right now, but I just want to make a point. Because I had a lot of people first hour ask me about that. They said, you said a quadratic has 2 solutions every time. And they do every time. But when it bounces, so if it touches the x-axis and automatically at that value bounces back up, it's technically touching the x-axis twice because it bounces on it. So we would write it in secondary math 3, x is equal to 0, and they say it like this, with a multiplicity of 2, because that happens twice. It bounces back up. But that's more advanced than we need to think right now, but I just wanted to make that point. So if we have something like this, a parabola touched down at -7, well, we get x is equal to -7, right? But we would say, since it touches down and bounces back up, that it has a multiplicity of 2, meaning it happens twice. But that's way more advanced than we need to be thinking right now. But I had a lot of people first hour ask me. So do you see how we would still have 2 solutions technically? Okay. Now understand something, graphing is just one method of solving a quadratic. It's not always the best method. In fact, I always opt to go with doing it by hand. Because I like to do it by hand, because then I don't have to deal with the calculator errors. And I like the algebra behind it. So I always choose to do it by hand, and really oftentimes you're going to have to do it by hand. So, first of all, you need to understand, right now we're learning how to solve a quadratic when it has the form ax squared plus c. So I'm missing bx, right, everybody? Does everybody see how I'm missing bx? Everybody listening, if you don't, you're not going to really grasp this stuff, and you're going to be a lost soul. So, once again, we're solving a quadratic today when missing bx. So I'm always going to say that in the future. Oh, remember we solve this when we're missing, this is the way we solve when we're missing bx. So we know how quadratics have the form ax squared plus bx plus c. Today we're learning how to solve it if it's of this form, ax squared plus c. Do you all understand how we're missing bx? Yep. That's the method we're learning today. You cannot use this method if you have a b. If you have a bx. Do you all understand that? So could we use this method that you're about to learn on this? Mm-hmm. Yep. Could you use the method on this? Yeah, we're missing bx. Could you use this method on this? No, we'll learn that later on how to solve that quadratic. Okay, so first of all, before we get into doing this algebraically, we have to know a couple of things background-wise. What squared equals 49? 7. So you're saying 7 squared equals 49. That is true. Can anyone think of anything else squared that equals 49? There's something else. -7. Good. -7 squared. Is -7 squared also positive 49? Yep. So you're saying the answer to this solution, this equation, this quadratic was positive 7 and -7. Isn't that the value that makes the statement true? Yep. So we have a positive and a negative answer, right? We have 2 answers. Well, that's true. We better have 2 answers or else this isn't a quadratic because we always have 2 answers. What squared equals 25? So 5 squared is equal to 25. There's another one. -5 squared is equal to 25. So the x value that makes this statement true is positive 5 and -5. So do you guys see somewhat conceptual understanding of the fact that if we have something like this, we're always going to have the positive and negative answer. Because both squared equal the answer. Okay, good. Okay, so here are the steps to solving a quadratic when missing bx. Take a picture of it, take it down in your notes, but I'm not going to stay long on this page. So if you follow these steps, you can solve a quadratic, but these are the steps you follow only if you're missing bx. So first, you have to isolate x squared completely, meaning get x squared completely alone. So nothing multiplied to it, nothing added to it. Then our second step is, once we've isolated x squared, we will take the square root of both sides of the equation to get x, because we know the square root undoes x squared. So once we have x, we can't forget when we take the square root to account for the plus and minus answer. We just learned why, right? So we're looking for this, what makes the statement true. And the plus and minus answer make it true. Now third, once you've done that, you have to make sure your answer is in the simplest form. So you might have to rationalize the denominator, and you might have to break down the square root by hand, because we know how to do that, right? Yeah. So if you get a decimal, and you're taking the square root, it's not an acceptable answer. I want to see you break it down by hand. Does that make sense? Okay. Let's practice. Here we go. Please ask questions as we go. I do not want to get out there and have you say, I didn't understand it. Well, you should have been asking questions. So here we go. Here's my examples. It says solve the quadratic equation. First of all, what am I finding? The what? The x-intercepts. When I'm solving a quadratic, I'm finding where it crosses the x-axis, right? So let's solve this one algebraically. So first of all, our first step is to isolate x squared. Nothing added to it, nothing subtracted. So we've got to get it all by itself. So I'm going to add 64 to both sides. So over here we have x squared. That adds up to be 0. Is equal to 0 plus 64 is 64. Is everybody following me?
Yeah.
So we have x squared is equal to 64. Well, we've isolated x squared. It's completely by itself. Then from there, we're going to take the second step, square root of both sides of the equation. So now our root cancels out with our power. We get x is equal to, you can't forget the plus and minus answer. So plus and minus the square root of 64. So x is equal to plus or minus. What is the square root of 64? 8. Now I need you to understand something. This just means x is equal to positive 8, x is equal to negative 8. I need you to split up your answers. So x is equal to 8, x is equal to negative 8. Questions on that? Okay, let's do another one. So let's go through this. So first of all, we have to isolate x squared completely. So we have to get x squared completely by itself. So what we're going to do is first, we got to do it in the correct order. We're going to add 126 to both sides. So we have 2x squared is equal to 128. So continuing. So then from here, what will I do?
Divide by 2.
Good. We got to isolate x squared completely. So divide both sides by 2. So we have x squared is equal to
64.
64. We've isolated x squared. So then what will we do?
Square root.
Square root both sides of the equation. So our root cancels out with our power. X is equal to plus and minus the square root of 64. So x is equal to plus and minus 8. So that's positive 8, negative 8. X is equal to 8. X is equal to negative 8. Questions? Couple more. So it says solve the quadratic equation. Once again, we're going to do it algebraically. So first step is isolate x squared completely. So what am I going to do? If we add 49, is that going to help us?
No. Subtract 42.
Good. This is positive 49. We've got to subtract 49 from both sides. So we have negative x squared is equal to negative 49.
Add a plus sign.
No, let's do the algebra. So what are we going to do? Technically, don't we have a negative 1 in front?
Yeah.
So we're going to divide both sides by negative 1. So we have x squared is equal to 49. And then we'll take the square root of both sides. So we have x is equal to plus and minus the square root of 49. 7. So x is equal to 7, x is equal to negative 7. Couple more that I'm going to let you work. Here we go. 3x squared minus 9 is equal to 0. Isolate x squared, so we add 9. So we have 3x squared is equal to 9. So then what will we do? Divide by 3. So we have x squared is equal to 3. Then what will we do? Square root both sides of the equation. So root cancels out with power. We have x is equal to plus and minus the square root of 3. Is that a decimal?
Yes.
Yes. Are decimals acceptable as answers? No. Does the square root of 3 break down? No. So we would leave it as the square root of 3. So we have x is equal to positive square root of 3. X is equal to negative square root of 3. Are you all feeling comfortable? Okay, last one. 4x squared minus 25 is equal to 0. Isolate x squared. So we'll add 25. So we have 4x squared is equal to 25. Divide both sides by 4. So x squared is equal to 25 over 4. If you get a decimal, when you do that, and you do, put it back in a fraction. So it's fraction. Leave it like this. So then we will take the square root of both sides of the equation. So our root cancels out with our power, right? So x is equal to plus and minus. Now because these are both under the square root, I'm going to split it up and keep them both under the square root, but split them up. Because isn't this the same thing as this since they're both still under the root? So what's the square root of 25? What's the square root of 4? 2. So it's plus and minus 5 halves. So x is equal to plus and minus 5 halves. So x is equal to positive 5 halves. X is equal to negative 5 halves. Now remember, that's where it's crossing the x-axis. These are the x-intercepts. These are the zeros. Are we all okay with how to do these? Okay, so I want you to do these problems. Well, stick with the problems that are on the board. I don't want you to do the other ones for right this minute. In a minute, we're moving on. So, stick with these problems. Ready, set, go. I'll give you a couple minutes to do those. So, first of all, we just learned that if a quadratic does not cross the x-axis, it doesn't have any real solutions, but their solutions, they're just imaginary solutions. So let's go through and solve. So a couple of things to know. The square root, this is just something you kind of have to have memorized. The square root of negative 1 is equal to I. So once again, the square root of negative 1 is equal to I. So, we pull out an I if we have a negative under the square root. So let's just start with something like this. The square root of 49, we know is plus, oops, I have my eraser on, sorry. Square root of 49, isn't that plus and minus 7? Okay, so I want you to look at this. A lot of students, when they first start, they think you can take the square root of a negative number, and you can't. You cannot. The square root of negative 49 is not just negative 7. But the square root of a negative 1 is I. So we can rewrite this as the square root of 49 times negative 1. Isn't 49 times negative 1 negative 49?
Yep.
So do you see how I'm rewriting it?
Yep.
To my advantage. What's the square root of 49? 7. What's the square root of negative 1? I. So there's our imaginary solutions. And we always have a plus and minus. So that's where we get our plus and minus, our two answers, but it's an imaginary solution.
So in other words, just add I to it.
If it has a negative under the root, you pull out an I. Now notice a couple things. The I came on the outside, right? A lot of people, like if they see something like this, like let's say we have a square root of negative 3. They'll say, oh, that's the square root of 3i. Not true. The I has to leave the house. Does that make sense? So we would have wrote this as the square root of 3, pulled out the negative, and have an I on the outside. But I was thinking a little bit in head. Let's just do a couple examples. It'll make more sense. Yes.
So it's only if you have a negative, you know?
Only if you have a negative under the square root, because the square root of negative 1 is equal to I. Do you have questions? You kind of are, like, you're looking at me with a scowl on your face. So, do you have a question I can answer for you?
It looks like the same exact stuff, but just different numbers.
Yeah, why'd you put it plain?
Why is it on the outside?
The I doesn't stay underneath the root. Is there a root anymore up here? No. So, there's not. It's not under the root. The square root of negative 1 is not the square root of I. That's why the I doesn't stay underneath. Do you understand what I'm saying?
So
I have to come on the outside. So, this is negative 1 times 3, right? So, the square root of negative 1 is I. So, you pull it I on the outside. I leaves. It's not under the root.
One's right. That one's wrong. That one's right.
No, that was wrong. That was right.
Wrong.
Right.
Right.
Yeah.
Wrong. Right.
Wait.
So the 49.
Oh dear. I shouldn't have done this example.
The 7i is wrong, but
No. This is right. This is a totally different example.
Okay.
So,
How about we do some examples, and then it'll make more sense.
I just look exactly the same.
yeah, why did you say 3?
I was doing an additional example, which I should not have done yet, because it threw you off.
I understand.
Okay, let's do some more examples here. Yes.
Do you have 2 of those for if it's
Yes, you would. Let's keep going, guys. Please, just bear with me. Guys, I've been teaching for a while now. If you'll just stay with me, it's going to make more sense. Here we go. So a couple examples. It says solve the quadratic equation. So the first thing we do is isolate x squared. So I'm going to subtract 8 from both sides. So we have 2x squared is equal to negative 8. What will we do next?
Divide by 2.
Divide by 2. So we have x squared is equal to negative 4. Then we'll take the square root of both sides of the equation. Root cancels out with our power. So we have x is equal to plus and minus the square root of negative 4. Well, isn't the square root of negative 4 the same thing as the square root of 4 times negative 1?
Yes.
Okay, what's the square root of 4? What's the square root of negative 1? So, no, it's not j, it's an I. Very different. So 2i. So we have x is equal to positive 2i, and x is equal to negative 2i. So we'll write it like that.
Why is 1 equal to I? Is that just like
No. The square root of negative 1 is equal to I. 2 in depth. Don't think so hard about it. Like right now, you're just going to have to trust me. We're not at that level to go through a proof of why and how it works.
Is it just like the new rule? Negative 1 is I.
The square root of no. Negative 1 is not equal to I, guys. That didn't just negative 1 didn't magically turn into I. It was the square root of negative 1 is equal to I. Do you see the difference?
Yeah.
Pay attention to little details, please. Yes. Okay, let's go through it. So what am I going to do?
Minus 5.
Subtract 5. So we have 2x squared is equal to
Negative 20.
negative 20. Then we'll divide both sides by
2.
2. So we have x squared is equal to negative 10. Then we'll take the square root of both sides of the equation. Root cancels out with power. X is equal to plus and minus the square root of negative 10. Okay, so let's rewrite it. That's plus or minus the square root of 10 times negative 1. What's the square root of 10? It's a decimal. Nope. The square root of 10. Does anything squared equal 10? No. So guess what? It's a decimal. Do we write decimals?
No.
So we break it down by hand. 10 breaks down into 5 times 2. Can we pull anything out? No. So leave the 10 underneath the root. But what is the square root of negative 1? I. So it's going to be plus or minus I square roots of 10.
Yeah, I can see that.
So x is equal to plus or minus I square roots of 10. So our final answer is x is equal to positive I square roots of 10. X is equal to negative I square roots of 10.
I get it.
Yes, I knew you would. So
Oh, I get it.
once again, if I say trust me, let's do some examples in the future. Don't argue with me. Just do it because I usually know what I'm talking about. Is everybody good? Okay. I need you to finish up through 21. Go. And then I'm going to do number 22 with you, and then we'll finish up the front. So I'm doing problem 22 with you, so you might want to listen so that you can finish up what I'm going to have you finish. So it says, find the side lengths of the square with an area of 196 feet. So this feet squared is just the measurement. So we're looking at a square, right? So we're looking at a square here. Do we know the side lengths?
Yeah. No, we know that.
We don't know the side lengths, so let's call this x. Well, aren't the side lengths of a square all the same?
Yeah.
So isn't this also x?
Yeah.
Well, it says the area, so this full amount is 196 feet squared, right? The feet squared part's just the measurement. I'm not going to write that in for right now. It's 196 feet. So we know area of a square or rectangle is length times width, right? So area is 196. So I'm going to write that in. 196 is equal to the length times the width. So x times x. So 196 is equal to x squared. Now can't I solve for x? Isn't this just a quadratic that's missing the x? So now we'll solve for x. Square root both sides. So we get plus or minus 14 is equal to x. Now, would the negative make sense? Would negative 14 be an acceptable answer for this problem?
No.
No. Could we have a negative side length?
No.
No. So we throw that answer out. We keep x is equal to positive 14. So our side lengths are 14. Does everybody see how to do that? So this is what I need you to finish. Up through problem 26. So due by tomorrow is up through problem number 26. Here is the, you don't ignore this one for today. Don't cross out the rest. Do not cross out the rest. But you will need the area for a circle. Area of a circle is pi r squared. Isn't pi just a number?
Yep.
Okay, so just keep that in mind. There's a pi button on your calculator. So everybody, you should go up through problem 26 and be able to finish it in the next 20 minutes before class gets out. Ready, set, go.
No, I don't want to delete.